The separate elements of MIWE bakery refrigeration systems are made in sandwich construction with an insulation core of rigid polyurethane foam. The insulation thickness is tailored individually to the specific application. Elements of different thicknesses can easily be combined to build a wall, bottom or ceiling. Depending on the relative humidity and the temperature difference between the cell interior and exterior, the dew point, in other words, the temperature range at which the moisture condenses, can be held in the middle. If the insulation thickness is, however, not perfectly designed for the temperature ranges, the dew point slides outwards. As a result, condensation occurs. As a basic principle, the doors of deep freezing units, which are often a weak point in integrated insulation, are 120 mm thick in MIWE products. A highly impact-resistant plastic frame prevents the creation of cold bridges and reduces energy loss to a minimum. The sturdy hollow chamber seal not only provides a perfect sealing, but is also very easy to replace. The great flexibility of MIWE bakery refrigeration systems in their cell bodies enables doors to be made in all conceivable versions, whether they are single or double doors, automatic fast mode doors or sliding doors. Whether or not they're equipped with additional discharge or service hatches, the variety, size and positioning of the doors are solely defined by the requirements of the customer. The cells of MIWE bakery refrigeration systems consist of modular elements that are manufactured accurate to the centimetre, customer specifically, individually and without a stringent grid dimension. They are characterized by quick assembly and flexibility for future expansions. The standard version of the cell bottom for the MIWE GUV, the MIWE GVA and the MIWE flash freezer is made of a sandwich element with a polyurethane core in which a pressure distribution plate is foamed in. A solid 2 mm thick steel plate constitutes the bottom flooring. A simple joint assembly of the elements can never guarantee the permanent secure sealing of the joints. Mechanical and thermal strains would quickly result in dreaded moisture ingress. This is why, at MIWE, the bottom plates are double-bended. The bearing surface thereby offers adequate contact for the applied high-performance sealing material. With the MIWE GUV, MIWE GVA and MIWE flash freezer system, the bottom plates are principally formed as trays. This not only provides effective protection from the ingress of condensate, it also makes cleaning considerably easier. As an option, MIWE also offers a bottom module without a pressure distribution plate. Instead, a stainless steel plate of 3 mm thickness is bonded permanently, self-evidently also formed as a tray. If maximum moisture protection inside the cell is a matter of course, further measures, particularly in the range of deep freezing, on the rear side of the base are required. The bottom ventilation duct has proved to be a simple but effective method to prevent sub-freezing temperatures. If necessary, it can also be combined with a forced ventilation system. Alternatively, an electric heater mat is used. Here, MIWE always passes 2 heating pipelines, better safe than sorry. In addition, a liquid heating system is possible, at low costs, by means of heat recovery out of the refrigeration system. The opening of the doors is jointly responsible for icing in the refrigeration cell. Cold air escapes and warm ambient air ingresses into the upper door area. Its moisture then condenses in the form of ice on the ceiling and on the upper wall areas. MIWE bakery refrigeration does not allow this to happen. The intake angle ensures that any ingressing warm air is taken straight to the evaporator. Especially for the proofing units MIWE GVA and MIWE GUV, as well as for the TLK dough storage cell, MIWE has developed the patented pressure wall system. Conventional refrigeration cells only blow the cold air through an opening into the chamber. High escaping airspeed and unfavorable airflow distribution in the chamber are the results. The MIWE pressure wall system, on the other hand, transports the cold air evenly to the dough pieces. Depending on the product and the stage of the process, the refrigeration control regulates the speed of the evaporator fans program dependently. Each dough piece only receives as much cold air as it actually requires. This prevents skin formation and ensures that your product quality remains persistently constant. For regular cleaning, the pressure wall elements can be removed easily and without any tools. Mold and such like do not have any chance. A best possible refrigeration capacity also requires an economically and technically optimized evaporator. This is why, at MIWE, the rib distances in its evaporators are individually adjusted to the specific application. Large rib distances, for example, increase the operating time, so that necessary defrosting processes do not affect the production. The use of MIWE Eco Recover also allows the economical defrosting of the evaporators using recovered hot water. If, for example, during shock frosting, extreme refrigeration capacity is required, powerful stationary evaporators are used. Here, patented adjustable fins ensure, even if the technology fails one time, an optional remote monitoring system built into the controls and a brief phone call of the MIWE voice computer ensures that failures do not remain undetected. Help will be at hand quickly and downtimes are reduced to a minimum. Ergonomics and intuitive operation were the main issues for the development of MIWE controls. These are not just units that control devices. They link the various processes in the production of baking products. They integrate what belongs together, all the stages from the use of refrigeration equipment to the baking of produced goods. Their programs and process controllers include the expertise of MIWE baking specialists that has been accumulated over decades. Only the perfect coordination of all production stages guarantees a smooth workflow in the baking room and perfect baking goods. The next step towards the complete networking of the various stages of production consists of automating them. MIWE Bakery Refrigeration Systems offers a bespoke solution for every product requirement and every space requirement for freezing, cooling, proofing and setting. The MIWE Spiral Freezer is ideal if you only have a small amount of floor space available. The products are transported through the various temperature zones in long circular spirals. This means that despite having a floor space requirement of only around 5 meters in height, belt lengths of up to 400 meters are possible. A cooling or proofing spiral can also be installed upstream if required. The MIWE step freezer is the system of choice if transporting them through a spiral would cause the quality of sensitive products to suffer. The number of levels and their lengths can be chosen to meet requirements depending on the specific needs and the available space. MIWE's step freezer offers maximum flexibility in a minimum of space. The MIWE tunnel freezer is a classic continuous refrigeration system for flat areas. A wide conveyor belt made of plastic or stainless steel passes through the modular system. For easier cleaning, the base sections that can be accessed through the doors are designed in the form of trays, and all the interior surfaces are made of stainless steel. The insulation thickness of 150 mm and specially insulated in-feed and out-feed section with an air curtain system ensure that energy is used sparingly. If your bakery is organized on the basis of rack trolleys, the MIWE rack trolley conveyor system may be exactly what you've been looking for. All the rack trolleys can be controlled individually and independently of each other, so that they can be exposed to different freezing, proofing and setting times. Flexible sections and extensions to existing systems can be installed with ease because the system has a completely modular design. Individual linear drive units, linear rotary units and automatic sliding doors make all this possible. From dough preparation to refrigeration systems, MIWE automation ensures that every stage of production interacts perfectly. They ensure that you achieve maximum economy whilst maintaining constantly perfect product quality. A major success factor for the bakery of the future. During the operation of refrigerating plants, valuable energy had simply been released to the environment up to now. In contrast, the heat recovery uses this energy and stores it for further use in the bakehouse. Through a valve in the evaporator, a liquid refrigerant abruptly transforms into a gas. It evaporates. Heat energy is necessary for this process. The evaporator takes this energy from the ambient air in the refrigerating chamber. The temperature in the refrigerating chamber falls. To re-liquefy the gaseous refrigerant, a compressor must considerably increase the gas pressure. This way, the refrigerant heats up strongly and has to cool down again to liquefy. Until now, the heat has always been irrevocably released to the outside air. To prevent this valuable energy from being lost, heat recovery intervenes. A plate heat exchanger transfers the heat from the hot gas to a water storage tank for later use. The achievable water temperatures are perfectly suitable for underfloor heating to prevent refrigerating chambers and freezers from developing frost underneath. Icy evaporators can be defrosted considerably faster and more cost-effectively than with the electric heating more commonly used. Climatic chambers can be excellently supplied with the necessary ground heat. Additional applications in the low temperature area are naturally also conceivable using heat recovery. From the beginning, MIWE integrates all the desired applications into the planning and design, therefore ensuring an efficient use of the produced waste heat in the refrigeration process and thus a complete economical solution.